You trust your eyes, right? After all, they show you the world colors, shapes, movement, everything. But what if I told you that your brain can and regularly does fool your eyes? That much of what you see isn't reality. It's a mental construction, a guess, and sometimes it's completely wrong. Let's start with the basics. When you look at something, light enters your eye and hits the retina at the back. The retina contains cells called rods and cones that convert light into electrical signals. Those signals travel through the optic nerve to your brain, where they're processed and interpreted. But here's the important part: your brain doesn't just process the signals. It fills in the blanks. And sometimes it fills them in incorrectly. Take optical illusions. You've probably seen the classic example of two lines that are the same length, but one looks longer because of the surrounding shapes. That's your brain misinterpreting spatial context. It's not a failure. It's your brain applying rules that usually help you understand depth, perspective, and motion. But in artificial or unusual situations, those rules break down. Or think about color. You might think color is an objective property of things, but it's not. Color is your brain's interpretation of different wavelengths of light. Context can completely change how you see a color. For example, take the famous viral photo of the dress. Was it blue and black or white and gold? People saw different colors because their brains made different assumptions about the lighting in the photo. This process is called color constancy. Your brain tries to keep the appearance of colors consistent in different lighting, but sometimes it overcompensates. That's why the same shade can look totally different depending on what surrounds it. Now let's look at how your brain handles motion. Ever been sitting in a parked car and the car next to you starts moving, and for a second you feel like you're moving too? That's your brain misreading visual cues. Your visual system is constantly trying to match what you see with what you feel. It's trying to make sense of the world based on patterns it's learned. This pattern matching process is incredibly powerful, but not perfect. For instance, look at the phi phenomenon. A series of still images shown in rapid sequence can appear to move. That's how movies work. Your brain fills in the gaps, creating the illusion of smooth motion. But in reality, nothing's moving. It's just still frames being shown quickly. One of the most fascinating examples of your brain fooling your eyes is the blind spot. Every person has a small area in their vision where the optic nerve exits the eye. There are no photoreceptors there, so technically, you shouldn't be able to see anything in that spot. But do you notice it? Probably not. That's because your brain fills in the blank. It guesses what should be there based on the surrounding visual information. You literally walk around all day with a gap in your vision that you don't even notice. It gets even weirder when you consider how expectations affect what you see. Your brain is constantly predicting what should come next. This is part of a concept called predictive coding. Your brain forms a model of the world, and then it updates that model as new information comes in. Sometimes it predicts so strongly that it overrides the actual sensory input. That's how visual hallucinations can happen. Not always from drugs or mental illness, but even in everyday life. Ever thought you saw a person or an animal in your peripheral vision, but when you looked, nothing was there? Your brain saw a shadow or a shape, made a prediction, and delivered a false result. This also ties into pareidolia, the tendency to see faces in clouds, electrical outlets, or even food. Your brain is so wired to detect faces that it would rather see a false one than miss a real one. Evolutionarily, this made sense. Detecting faces, especially emotional expressions, was critical to survival. So your brain errs on the side of false positives. Let's go deeper into how your brain uses shortcuts. Because it processes an enormous amount of data, it uses heuristics, mental rules of thumb, to make fast decisions. These are incredibly efficient but prone to errors. For example, the Mueller-Lyer illusion two lines of equal length appear different because of the arrows at the ends. Your brain is applying a depth cue that works in three-dimensional space, but the drawing is flat. So you're tricked. Even in real life, your eyes can deceive you when your brain uses the wrong rule for the situation. Pilots flying in clouds can feel like they're flying straight when they're actually tilting dangerously. That's called spatial disorientation. And it happens because the visual system and the inner ear give conflicting information. and the brain bets on the wrong one. And remember, your brain can also edit what you see after the fact. There's a phenomenon called change blindness. You can miss huge changes in a scene if your attention isn't directed to them. In one experiment, someone starts talking to a pedestrian, and mid-conversation, someone else swaps in and takes their place. Most people don't even notice the change. It's not that their eyes didn't see it, it's that their brain didn't process it. Your perception of reality is filtered through what you pay attention to. So what does this all mean? It means that what you see is not raw reality. It's a mental reconstruction, a simulation built by your brain using a mix of real sensory input, memory, context, and prediction. Most of the time, it's incredibly accurate. But under the right or wrong conditions, your brain can fool your eyes completely. It's not a flaw, it's a feature. The system evolved to help us survive, not to show us the objective truth of the universe. So the next time you swear you saw something that wasn't there, or you're sure a color looked different just moments ago, remember this: your brain isn't lying. It's just doing its best, with limited data, in a chaotic world. And sometimes that means seeing things that aren't really there.